Good day, everyone, and welcome to where we are putting together solutions for students who are struggling in the area of primary math. And we'll be looking at the secondary entrance assessment, the SEA, for the year 2022. Since we are breaking it up into parts for students who are struggling, we'll be looking today at section 1. Don't forget to like the video and add any comments down below so we can help create other videos in areas where you are getting problems. This is our primary math channel. We also have one for CXC Mathematics for all papers from 2009 until present. And we also have for Form 5 CSEC Additional Mathematics from the time CXC started AdMath in 2012 until present. Let's now look at the paper and the way the questions were distributed in this first section, these first 20 questions. So the first strand, as you remember, that SEA is broken up into 4 strands. The first strand is number. It takes up the largest part of the curriculum. Almost half of the topic is number. So for the first 20 questions, numbers 1 to 10 are based on that strand. And then the next strand is measurement, where the next 4 questions are assessed there. Then we have geometry, where it is assessed for the next 3 questions, which are 15 to 17. And to complete section 1, we have statistics, which are the last 3 questions in this section. So now let's go look at the actual past paper, where in number 1, the question asks, write the numeral for 35,096. And of course, some students could immediately write the answer, and that's fine. And just for a little reminder, let's consider putting it into a little table where we know if we're putting the place value, we have ones and tens and hundreds. And of course, math is a pattern, so it repeats. So what comes after ones and tens and hundreds? Ones and tens and hundreds. And if we had to go again and was a larger number, it will be ones and tens and hundreds and keep repeating like that. So the first sets are with ones and tens and hundreds. That period or those 3 places are ones. And then the next 3 ones and tens and hundreds are under thousands. And if we had another set, it will be ones and tens and hundreds under millions and continuing. So if we look at our question, 35,096, 35 would be 3 tens and 5 ones. 35, and it's under the family of thousands. And now we have 96. So are we seeing, we finished with the thousands, we're now moving to the family of ones. Are we seeing any hundreds? There are no hundreds. There are 90, which means 9 tens and 6 ones. So that's how we end up at 3535096. Some people either leave a space between the thousands and the zeros to represent 2 different families. Some people put a comma after the 5. It's your choice. So let's go look at number 2 now. In that question, sorry, the number 875 is increased by 625. What is the new number? So some people could work it out in their heads and get the answer, and that's fine, which is 1,500. Others would like a little diagram In this case, there are so many different ways to work out every question in this paper. So we'll draw an open number line and randomly put where the first number we're starting with is what? 875. And now we're increasing it. So that means we're getting larger, or we're adding. So that means on the number line, we're moving to the right. Now we can increase by either 600 or 20 or 5 or 25, anything you want. So since teachers normally encourage students to use the ones first, the value in 625 with place value 1 will be 5. So if we have 875, we can add 5 to it, and 875 plus 5, 75 plus 5 is 80. So we're going to get 880. And now we can add, after we added the ones, we can look at the place value of tens, and we see what do we have? 20. So we can add 20 to this number. So we're still increasing it. And if we add 20 to 880, what will that give us? It will give us 900. And now we've increased by 5 plus 20, that's 25. So the only thing we're left to increase by is 600. And that would cover everything. So if we have 900 and we want to add 600 to it, so 9 and 6. So we have 9 and we could count on 10, 11, 12, 13, 14, 15. So we have 1500s or 1500, which was said above. It's 1 mark, so you can do working if you want, or you can just write the answer, and that is fine for this part. Another way we can work it, which many teachers prefer, would be if you do the simple addition, 875. Increase means to add by 625. And if we're adding, which ones do we start with first? The ones with the hundreds, the tens, or the ones? Well, we add the ones first. So 5 and 5 is 10. And we would like to write a number under the ones column. So we could cross out the 0 and put it in there. Great. So now we've completed the ones addition. Let's now look at the tens place values. So if we're in that column, we have 7 and 2. That's 9. And one more, that because we have 1 from the first thing when we're adding the ones, we're left with 10. So we have 10 tens. How do we write 10 tens? How many tens is that? We could cross the 0 and put it here. And 10 tens means we have 100. So we have 800 and 600 and 100, which is 8 and 1, 9, 900 and 600. If you notice, if we look at our number line, we're doing the same thing. We started with the 5 and we added 5. And then we added the 2 for the 20, right? Which means we're now adding the last part. So 8 and 6 is, you can count on. You can use your fingers if you want, or if you know it by heart, that's fine. Sorry. So 8 and 6 is 14, and 1 is 15. So 1500s means we have 500s, and the 1 is 1000. So the answer is 1500. So we've seen a couple different ways to work out this question, and every question is just like that. Let's now go on to number 3. And in number 3, they're asking us to divide 372 by 12. And there are so many different ways to work this question. For some of my students, they prefer that if we think about 12, can we look at how many 12s there are in a simple multiplication table? Well, we know 12 tens are 120. So instead of dividing the whole 372, we can break it up into parts. So let's look at the first part, 120. how many groups of 12 can I get in that? I can get 10 groups of 12. Remember, dividing by 12 means finding groups which are the size of 12. So we have 10 groups of 12 will give us a 120. So out of that 372, we have catered for 120. Can we find another 120 in there? Well, yes, we can. So in that case, that means we're going to get another 10 groups of 12 or 10 dozens. So the first 10 dozens or 10 12s will give us 120. We have another 120, so we could get another 10 groups of the 12. So that means we catered for 120 and 120. So we've catered for 240 of those that we've divided already. Can we get another set? Well, it seems so. So if we add another 120 in there, that means we're catering for 360. So if we were sharing up toys, we didn't have to share up all 372 into 12 one time. We could have pulled out 120 of the toys and shared it up in groups of 12. We would get 10 groups, and another 120 would give us another 10 groups, which means we covered 240 toys. And if we had another 120, it means we would cover 360 toys. And that would give us, the last 120 would give us another 10 groups of 12. And how much more do we need to reach 372? We're already at 360, so we are lacking only 12. So if we just find out if we have 12 toys, how many groups of 12 can we get from 12 toys? Only one group. So what does that mean? It means that in all we form 10 and 10, 20 and 10, 30 and 131 groups. So we've shared up 372 into 31 groups of 12. Another way we could do it, we can do normal division. 372, that's 100, 200, 300. And how many tens? 7 tens. 1, 2, 3, 4, 5, 6, 7. These are the normal base 10 blocks that your teachers use in class all the time. And 2 ones. So let's think about that. We have 372. We've seen it breaking up in parts on the left-hand side. And on the right-hand side, what are we doing? We are actually seeing the values of each using the base 10 blocks or Dean's blocks. Now, what do we want to do? We want to divide them by 12. We can use long multiplication, we can use short multiplication, whichever one. So first of all, we have 3 hundreds. You can see them up there, the 3 big squares, 10 by 10 squares. Can I get 12 groups from those 3 squares? Well, not how they're looking presently, but if we replace one group of 100 by 10 tens, and I now replace another group of 100 by 10 tens, and I replace the last group, so that's another 10 tens. What does that mean? We tried to divide 12 into 3, meaning we had 3 of those squares and we wanted to form groups of 12 and we couldn't. So we looked at now, not 300s, where we replaced it by 30 tens, and we had 7 tens from before. So we have 37 tens. Can we form groups of 12 there? Can we package them out so they're in groups of 12? Let's see. Well, if we go 4 by 3 is 12. So we got one group of 12. And what is that group? A group of tens. Right? We got a second group of 12. Can we form a third group of 12? Let's see what it means. 4 and 4, 8 and 4, 12 and one more. So we could get a third group of 12. So we had 37 of these tens or rods, if some of your teachers use that term in class. And out of those 37, we were able to form 3 groups of 12. So we had 3 groups of 12. Each group was made up of the tens or the rods, right? Good. And what do we have remain? We have 1 10 and 2 1s. So some people could work with it right here to form a group of 12. Others will say, well, they're not the same. How do I share that up? Can I find a group of 12 from there? Well, I can take 1 10 and let's write it there because that's the remainder. I'm trying to use the terms your teachers usually use in class. And do what? We now have 1 10 and 2 1s. So we can replace the 1 10 by 10 1s and 2 1s. We have 12 of those ones or 12 units. Can we form a group of 12 there? Yes, we can. So we're getting one group of 12. So in 372, we were able to form 31 groups of 12. Let's continue. Let's look at number 4. So we have 1/7 of some number is equal to 19. So the question is asking us, well, what is that number? What number, when we find 1/7 of it, is equal to 19? And there are so many different ways to work it. Let's look at an idea. Imagine this is a number. We don't know how much it is, but we know if we had cut it into how many parts? 7 parts. So each part is 1/7. So we have 1, 2, 3, 4, 5, 6, 7 parts. Try to put them in a little different color so you could see that 1/7 of this whole rectangle is equal to 19, which means one of these parts is equal to 19. That's 1/7, that fraction. And the other part is also 1/7, that's 19. And we would have a third 19, a fourth 19. How many 19s will we have in all? We should have 7 of them. Because if we remember, if we have a large item and we're cutting it up into 7 parts, it will be 7 equal parts. So each part will be 1/7. So 1/7 of this large rectangle is equal to 19. What is that large rectangle? Well, if we know it's 19 plus 19 plus 19 7 times, we will be able to get our answer. And if we're repeating this addition over and over, a quicker way to do that will be by multiplying. So we could say 19 times 7, and 9 sevens are 63. So we can write that. And we want to write something under the sevens, the units. So we cross out the units 3 and write it there. And we have tens now. We have 7 sets of tens. 7 ones are 7, and we had 6 tens from below. 7 and 6 is 13. So we want to cross out the 3 and write it there. So we have the 133. This can also be written as, instead of saying 19, we could say 20 minus 1. And 20 minus 1 repeated. Some people find it's easier to count like that, 20 take away 1 or minus 1 rather than writing 19. So if that was the case, we would have, imagine we have a $20 bill and then we'd have to pay $1 out of it and that will give us 19. So how many $20 bills we have? 7. 7 20s. 5 20s are 100 and 20, 140, 140. And we're taking away 1 each time. So we're taking away 7. 1s are 7. So 140 take away 7 is 133. So look how many different ways we've been able to find this solution. Another way we could think of it, since they are equal, then it's just like sitting on a seesaw. Everything is balanced. So if we have 1/7, Let's take a circle and bring up 1/7 of that circle. That is the same as 19. 1/7 of this whole circle is equal to 19, which is what our first line is telling us. So if we add another 19, we need to add another 7 in order for them to balance. It's a seesaw. And if I add another 7, it means I add another 19. And I add another 7, 1, 2, 3, 4 sevens. It means I have 4 sets of 19. 5 sevens means 5 19s. 6 sevens means 6 19s. And 7 sevens is 7 19s. And 7 sevens would mean the whole entire thing. So if 1/7 was 19, we want the whole thing, we would need 19 sevens. And it would still give us the same answer. Just trying to give you a visual idea in terms of you being able to connect what the question really looks like in your mind as a picture. Let's go. Let's look at number 5. And in number 5, they're asking us, circle the number that is not a square number. So we have 9, we have 12, we have 16, and we have 25. Which one is not a square number? Some people know it by heart and they can easily write the answer. Others will say, well, listen, I have a square. I put 1 square there. If I put 1 square, is that a square number? Well, is one side, we can imagine the length is 1, and the other side, because it's a square, is 1. So 1 square, 1 small square forms a square of side 1. So 1 is a square number because it can form a square. What about if I put 2? If I put 2 squares together, is that a square number? Can I form a square from it? No, I cannot. If I put 3 together, can I form a square from those 3 numbers? From those 3 squares? Can I get a larger square? Can I rearrange it somehow? No, I can't. What about if I put 4 squares? Those 4 squares, could it be rearranged to get a larger square? Well, yes, we can slide it down and look. Here we have a larger square, which is 2 across by 2 down. So we now realize that 4 small squares form a larger square of side 2. So 4 is a square number. If that's the case, is 5 a square number? If we rearrange it, can we get a square? No. Is 6 a square number? No. 7, 8, 7, no. 8, no. Can 9 be? That means we're adding 3 more squares. But if we add the 3 squares below, then that gives us 9 small squares forming a larger square. As such, 9 is a square number, which is what is up on top. And what did we do from blue to get the next square number? We added 2 to the right and then 3 more at the base. So how do we go to the next step? If we add 3 more, that will give us 9 and 3, 12. Is that a square number? Can we rearrange it to get a square? If we take the 3 and put it below, will still not be a square. So therefore, 12 is not a square number. But if we add how many more to get a square? We need 1, 2, 3, 4 below. So if we add 4 more below, we'll get a large square. So how many do we have in all? 4 sets of 4, which is 16. So 16 small squares form a large square of side 4. So 16 is a square number. What about if we add right around 4 on the right and 5 below? That will give us the next larger square number. So that will be 5 rows of 5. 5 fives are 25. So 25 small squares form a larger square. And that will have sides 5 by 5. And if we wanted the next square number, we could just continue the pattern, and you can see it as 36. So the question asks, circle the number that is not a square number, which means you cannot form a square with those number of small squares. 9, we could have rearranged it to get 3 squares across by 3 squares down, right? We would get 9. 16, we'd get 4 by 4, 25, 5 by 5, but 12, we could not get that. So let's go on now. We're moving to number 6. Sorry. Number 6. Calculate 11 twelfths minus 2 thirds. And of course, students are taught many different ways to do this. We can take a large sheet of paper like this and try to fold it. Now, how many parts do we want to fold it in? Well, we could try and fold it down the middle like that. We can fold it and open it back out. So what do we have? We have split it into 2 halves. Can we fold those halves again one more time? Then we will get quarters on either side. So we've broken it up into 4 parts. 1, 2, 3, 4. Great. Now we want to get how many parts? We're looking at the first term, 11 twelfths. How many parts do we want to get? 12 parts. Remember, the denominator, the number below, means how many parts there are for the whole. So if this whole was this rectangle and we wanted to get it into 12 parts, then what do? We folded it into 4 parts. And how do we get the next set in order to move to 12? We can fold it this way. So if we fold it across, or if you are sketching it, you can do this in the exam. Make a quick sketch, a large rectangle. Look what we did. We folded, we drew a line down the middle, so we split it in 2. And for each one of those, we drew a line down the middle of those, so we split it into 4. And 12 is 3 sets of 4s. So if we drew these lines across, we'll get 3 rows of 4, which is 12. And how many of those 12 parts are we interested in? 11 of those. So if we shade those, 4 and 4, 8, 9, 10, 11. 11 twelfths. So we have 11 twelfths. That's the first part. And now we want to get 2 thirds. So we can take the same whole, because we know that's 11 twelfths. Let's look at the same whole. I'm going to put it one side first, and then we're going to fix it. And we want to cut it into thirds. So how do we cut it into thirds? By going across, just like how we did this one on the left. So if we go across, we've cut it into thirds. How many thirds are we interested in? Look at the numerator. The number is 2. So let's shade that. We have 2 thirds. And since we want these 2 fractions to have an operation of subtraction, then we need to have the parts in the same size. So how do we get the same size parts? Because on the left side, each of those small parts are twelfths, but on the right side, each of those parts are thirds. So if we split on the right side those into 4 columns, then we have each of them carrying the same size parts. The left side, the small parts are twelfths, and on the right side, the small parts are twelfths as well. So how many twelfths were shaded? It was the same green, which was 2 thirds, and now the way we cut it, it hasn't changed, but we're using smaller parts now. How many parts are there? 12 parts, and the green is 8 out of 12. As such, we can rewrite that up on top, 11 twelfths minus 2 thirds to be 11 twelfths minus 8 twelfths. So we have 11 twelfths, and this group, which we have in green, we would like to subtract it or take it away from those yellow ones. So one way we can do it, we can just slide it across so you can see when one is on top of the other, that what we are left with, what was not touched? The 3 yellow ones. So it is 3 twelfths. So 11 twelfths minus 2/3 is the same as 11 twelfths minus 8 twelfths. And if we have 11 of an item and we're taking away 8 of those, we're left with 3 of those items, 3 twelfths. Can I just draw that back, 3 twelfths, so you can see it? 3 out of 12 parts. What about if we rearrange it? I take one of the yellows and move it above. So it looks like that. Okay, let's move the other yellow. So we can see it's still 3 twelfths. Each case, it's the same. 3 squares out of 12 squares. I just rearrange it a little bit like a puzzle. So what happens now if we take off those lines going across? Then we have, it is 3 twelfths, is now 1 out of 4 parts. So 3 twelfths is equal to 1/4. Let's go on to number 7, where the question is asking us to calculate 6/7 of 84. So some people could quickly work it out and get the answer, and that's fine. Some of us want to look at it like it's a picture. So we have 6/7 of 84. Let's consider 84 to be the whole, and we're looking for a fraction of that whole. So 6/7 of 84, or multiplied by 84. So let's think of 84 here, and we want to cut it into how many parts? 7 parts. So let's consider 1 part, 2, 3, 4, 5, 6, and 1 in the 7 in the middle. That's 7 parts. So if we consider that's the case, we have 84 as a whole, and we cut it up into 7 parts. We are interested in how many of those parts? 6 out of those 7 parts. So let's look at one of them first. So one of them will be this little place here, 1 out of 7. Trying to use different shapes so you get a bigger way of looking at the question at different angles. So we had 1, 2, 3, 4, 5, 6, 7 parts, and we're only thinking about one part out of those 7 parts. So if the whole thing is 84 and I want to get 1/7 of that 84, then 7 into 7 is 1, and 7 into 84, well, we have 8 tens, 1, 2, 3, 4, 5, 6, 7, 8 tens, and we have 1, 2, 3, 4, 4 ones. And if I have 8 tens, can I get a group of 7 made, and so forth? We can do it that way. Or we can say, let me take out one of those. If you look at them, we have 8 tens, but we only need 7 tens. So one of those tens are extra. So I can take out that 10 and make it 10 ones. Now, how can if we look at that, can we get that into 7 parts? Well, 1 part, 2 parts, 3 parts, 4 parts, 5 parts, 6 parts, 7 parts. I'm showing it a little differently from how we did before. You can do it like how we did in the last question. That's fine. Or you can do it this way. Just trying to show you different ways of approaching the question. Just like in life, math is teaching us that there are so many different ways to tackle any problem. So we got 7 groups, and we were interested in only one of those groups. So let's look at the top one. So this is 1/7 of 84. And how much is that? 10, 11, 12. So 7 into 84 is 12. Great. And how I can put that here in the hexagon on the left-hand side. So those 1 part is 12. And we want to get how many parts? 6 of those parts. So we'll have 12, a second 12, third one, fourth, fifth, sixth. 6 of those parts out of the 7 is what we're interested in. And that means we want 12 and 12 and 12, 6 of those, 6 12s. That could also be shown on the right side, 1, 2, 3, 4, 5, 6, all turning green. That is what we're interested in. 6 out of the 7. So that is, if we count it, if we count the tens, we have 6 tens are 60, and we have 12 on that side, that's 72. So the 6 sevens multiplied by 84 is 72. Let's go on now to the next question. So what is number 8 asking us to do? It's saying write 47 over 5 as a mixed number. And there's some of you could watch it and immediately say, well, that's the answer, 9 and 2/5. That's fine. And you will get your mark for that. For others, we just have to make sure we understand what's happening. So if we consider a whole, one whole, and look at the denominator, the number below, what is that telling us? We're interested in 5 parts. So for each whole, we're going to split it into 5. So one whole will give us how many parts? 1, 2, 3, 4, 5 parts. And of course, we could put a little counter here for us. One whole took up 5 parts. And if we used another whole, that will give us another 5 parts. So in total, we have 5 and 5, 10 parts out of the 47. So those 10 parts give us 2 wholes. If we add another one, and we'll just go through this process to make sure you're following, that will give us 15, which is 3 wholes. So 15 parts, where each part is a fifth, will make up 3 wholes. Another one gives us another 5. That makes us 20. So we have 4 wholes. 1, 2, 3, 4. If we're taking a fifth pizza and we're splitting it, we're going to get 5 parts from that as well. So we'd have 25 parts in all. We haven't reached this yet. So let's go again. We have another 5 parts with 6 of them. So 6 fives are 30. And we have to go again. Another 5. So that'll give us 35. So 35 parts made us 7 wholes. Another 5 means that we're getting close. It carried us to 40. So 40 fifths is the same as 8 wholes. I need to get 47. Can I get another whole again? I should be able to. So that will give us 9 wholes, which is 45 parts. And what are we missing? Just 2. One more thing with 2 parts involved. So that will be 2 more parts, 46, 47. So we've catered for everything. So that means 9 wholes and 2 remaining, right? So it's 9 wholes and 2 fifths is 47 over 5. This, of course, is a little longer method, but many of your teachers like to teach this version. Let's just go and say 47, 5 into 47. So we do a division. 5 cannot go into 4, but 5 into 47. We know our 5 times table. 1 5 is 5, 2 5s are 10, and you go up. 8 5s are 40, 9 5s are 45. And we have a little remainder, 46, 47. If you look on your left side, you saw 9 of those 5s are 45. We have 2 remainder. So that remainder, 9 remainder 2 is written as 9 and 2 fifths. Let's go to number 9, which is asking us, the maximum score of a spelling test was 50. Anika scored 60%. What was Anika's score on the test? So there are many different ways to do this question. We could picture it as the whole entire test is worth 50 marks. So let's write that. And let's say we split it into 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So it's still, the whole thing is 50, but we've split it into 10 columns. And we could split it in 10 across as well. So that's 10 tens are 100. So we can imagine 100 of those small blocks is equivalent to 50 marks. So it can be rewritten 100% is equal to 50. 100% is the whole. So can we find for 1%? We can divide by 100 on both sides. So 100 over 100 is 1%. It's 50 over 100. So we found for 1. And how many percent do we want to find? Anika scored. Let's represent that 10, 20, 30, 40, 50, 60%. So she scored 60%. And if each percent is 50 over 100, which is a half, then we had 60 halves. So 60% is 50 over 100 times 60. 50 over 100 is a half. What is half of 60? 30%. 30 marks, sorry. So Anika's score on the test was 30 marks. And that's fine. Some people prefer to do it this way. There are many different ways. I'm sure your teachers showed you. So we have 0% is nothing, 10%, 20%, straight up to 100%. So 100% represents all of the marks she could have gotten in the spelling test. So if she got 0%, she get 0 marks. If she got all the marks, 100%, she'd get 50. So if we think about it this way, can we break that up into tenths? So what is 1/10 of the mark if she got? If the whole thing is 50, one column is 1/10 of the mark, would give us 5 marks out of 50. And if she got 20%, another 10%, she get 5 and 5, 10. And she got another 10%, she'd get another 5 marks, so that's 15. And keep going, she'd get another 5, 20. And half of the marks in the test, she would have gotten 25. So some students find when they're looking at the question, well, if she got half the marks, 50%, she got 25. So I just need 10% again. So another 10% is 25 and 5 is 30. So she got 30 marks out of the 50. And some teachers traditionally like to say, what is 60% of 50? Well, that's 60 over 100 multiplied by 50. And of course, we can say 10 into 50 is 5. 10 into 100 is 10. 10 into 10 is 1. So 10 into 60 is 6. As such, we're left with 1 below, which is fine, and 6 5s are 30. So Anika got 30 marks out of 50 in the spelling test, which is 60% of the marks. Right, let's go on to number 10, which carries us to half of the section. Sam bought 2 of the bottled water shown below. So we have a bottled water, and the cost is $4.25. How much change did he receive from $10? So if we have one bottled water, it's $4.25, and he bought how many? He bought 2 of them. So let's put another $4.25. So we have $4.25 times 2, or $4.25 add $4.25. So 25 and 25, or if you want to go 5 and 5, that's fine. 5 and 5 is 10. So we're looking at the units as 0. And let's look at the tens now. 2 and 2, 4, and 1 is 5. Or some people could say 25 cents and 25 cents is 50 cents. So we could put the decimal point there. And $4 and $4 is $8. So what does that mean? It means Sam bought 2 of the bottled water shown below, and it cost $8.50. If she's paying a total of $10, that's how much he's giving the person, and he's paying for those 2 bottled water, which is $8.50. What is the change? How much remains? So hopefully you realize that the entire thing is $10. And he's paying for that $8.50, so we could subtract $8.50. And if we work that out, let's start on the extreme, right? We have 0 minus 0, that's 0. we have 100 minus 85 is what's left, or 0 minus 5, and that cannot happen. So we need to borrow. Can we borrow from the 0? We cannot. Can we borrow from the 1? I'm trying to use the terminology that teachers use, right? So we're actually crossing off that $10 and making it 9, and we're carrying it across, so we'll have 10 cents. So we have 10 cents minus 5 10 cents is 5 10 cents. And since it's cents, let's put the point. And we have $9 minus $8 is $1. As such, our answer is $1.50. Okay, so let's go on now to number 11. Number 11, what is the length of the pencil in centimeters? So if we notice that the ruler there, where the pencil lies, is not at the starting point of 0, where the pencil point is on the left. And that usually causes some issues for some students. Some students can watch it and quickly work it out and get the answer. Let's just clarify what's happening. There is a ruler at the base, and if we look at where the starting point is, the pencil starts at roughly 3.5 centimeters. And let's recall that that is basically a ruler there. And if we shift the ruler down to 0, we will see that it ends where the number 7 is. So we can tell the answer. Another way to do it, we can see the starting point is 3.5 centimeters, and the ending point at the end of the eraser is 10.5 centimeters. So what's the difference? 10.5 minus 3.5. So of course the halves will cancel, and 10 minus 3 is equal to 7 centimeters. So it's just the idea for students to recognize that we can shift the starting point 3.5 centimeters down to the left, which is what we did with the ruler sliding, the purple one. And therefore 10.5 will shift down 3.5 centimeters. Both things are moving 3.5 to the left. That's why we said 10.5 minus 3.5. A half minus a half, they cancel, that's 0. 10 minus 3 is 7. So let's now move on to number 12. And in number 12, notice that we've moved past the number strand, which was 1 to 10, and 11 and 12 and so forth will be going on to the next strand. So 12, write the time shown on the clock below. And of course, some students can easily tell, and let's clarify what happens if we extend a green line from the center straight through. We're looking at the hour hand. We can see it's almost 10, but not quite. It's a little more than 10. But if we extend it again to where the hour hand would be 11, we're seeing that our hour hand lies between 10 and 11. So it has not reached 11 as yet. As such, when we're talking about hours, it will be 10. And now, let's look at the idea of the minute hand. So, of course, from the center, we can extend the 4 quarters, showing where 0 minutes are, and where half past is 30 minutes. And from 0, that would indicate with the red arrow that if it was at 10 o'clock, the line would be there, but we're a little bit to the right, pointing at 1. So when we're talking about minute hand, we're moving from 10 o'clock, 10:00, to 1 minute past, 2 minutes past, 3 minutes, 4 minutes, until we reach that point there, facing the 1, which is at 5 minutes past. So it's 5 minutes past 10, or 10:05. Okay, let's go on now to number 13. Sorry, excuse me. How many pineapples of the same mass will balance the scale? So right now, we can see there's a 3 kilogram weight pressing down on the left-hand side. And of course, that 3 kilogram weight is heavier than the 500-gram pineapple mass. So the seesaw is bent. And if we want it balanced, notice that some things are in kilograms and some are in grams. Do you remember the conversion? What does kilo mean? That prefix kilo means 1,000. So we can say 1,000 grams is the same as 1 kilogram. And therefore, what about if we cut each side in half? So 1,000 divided by 2 is the same as 1 divided by 2 kilograms. 1,000 divided by 2 grams, 2 into 1,000 is 500 grams, and that's the same as half a kilogram. Now, what is 500 grams? It is a pineapple, and it can be represented as half a kilogram. So, I like to do it a little differently. When we think about a half, let's picture a circle. So, let's say half a kilogram would be half of a circle. So, if we have half a kilogram and we put another half, we will get 1 kilogram, which means that's the weight of one pineapple, and one pineapple, which is 2 pineapples. And we add another half a kilogram, that's 1.5 kilograms, and another one, 2 kilograms. So that's 1, 2, 3, 4, 4 pineapples. And we go again, 2.5 kilograms, 3 kilograms, the same weight as the left-hand side. So in order to balance the scale, our balancing means that we need 1, 2, 3, 4, 5, 6 pineapples on the right-hand side. And then the scale will be balanced. So good. Let's move on now to number 14. An empty container and a full carton of milk are shown below. The container holds 5 liters, while the milk carton is 250 ml. How many cartons of milk will fill the container? And there's so many different ways to do this. So you can draw a number line. Say 0, 1 carton of milk, 2 cartons of milk, 3 cartons of milk, and so on. So that's 250 ml, and another 250, and another 250. So that's 500, 750, 1,000 ml, 1,250 ml, and continuing, according to how many cartons we want. And what do we know? 250 milliliters will be the same as 0.25 liters, 0.5 liters, 0.75 liters. 1,000 ml is 1 liter. So if we want to look at the idea of how many liters there are, we know that for 1 liter holds 1, 2, 3, 4, 4 cartons of milk. And in our large container, our container is 5 liters. So that will hold 4 times 5 cartons of milk. Right? If 4 cartons make up a liter, and we want 5 liters, then we'll have 4 fives are 20 cartons of milk. So 20 cartons of those small milk packs, if we empty it into the container, will fill the entire container. 4 cartons would only fill 1 liter, and another 4, another liter, and another 4, and we have 5 sets of those. 5 fours are 20. So in number 15, the cross-section of the prism shown below is a square. What is the name of the prism? So if we think of the cross-section means that we can cut it, and if it's a square, the left side or the height and the width are the same. So that means this is a square. And if we cut anywhere as we go along that path, we will still be getting a square, straight until we reach the back of it, the same size. And that's the point of a prism. The cross-section remains the same. Now, It looks similar to things we know. So if we said that we went down the length, the same distance as the height or as the width, then that means that distance we have in brown is the same length as the front, the width or the height, and the top would be the same. Then if the shape stopped here, then it would be considered to be a cube because the length, breadth, and height would all be the same. But if you look at this shape that we had, the shape is even longer than that. So therefore, it is not a cube, but a cuboid. All right, so let's go on to number 16, which says, which of the shapes below is not symmetrical? So if we talk about symmetrical or line of symmetry, or other teachers use the phrase mirror line, it means can we fold the shape along a line so one side fits over the other side perfectly. So let's look at the first shape, our little aeroplane, shape W. Can we fold that in a particular way so one side fits over the other? Where would that line be? Our mirror line would be down the center. And if we look at the right-hand side, let's color it. If we folded that over the mirror line, would it be on the left-hand side? Yes, it would. So therefore, W is symmetrical. Our question is asking us which one is not symmetrical. Okay, so let's look at the X, which I believe is a butterfly. Can we fold it in a particular way so they fold perfectly one side over the other? Well, if we draw a line straight up, we can see that what is on the right-hand side, we can fold it and it should fit perfectly over the left-hand side. All right, so X and W, the first two shapes, are symmetrical. Let's look at Y. Looks like an apple. Can we fold this in a line where we're getting it to be symmetrical? We have a mirror line. Well, if we look at the base, we know it's going to go in the middle through the base. So let's draw a line straight up. And if we look at what's on the right-hand side, if I bring it across onto the left side, does it fit exact? No, it doesn't. Because the leaf on the right side, there's no leaf on the left. So therefore, Y is not symmetrical. And that is our answer. We can go through Z and you can take a look at it as well. If we fold it for it to be fitting one side over the other perfectly, we can draw a line straight down the center, our mirror line. And what's happening on the right-hand side is exactly what's happening on the left-hand side. So W, X, and Z are all symmetrical shapes, but Y is not symmetrical. All right, let's go on to number 17. In this, we're looking at an angle. Which triangle below has an angle that is greater than a right angle? So we have A, one type of triangle, B, another type, C, a third type, D, kind of looks like B, right? Slightly different. So let's bring up the idea of your teachers would have done 90-degree testers with you and 45-degree testers. So a 90-degree tester would just be like the corner of your page. So let's bring up one here. Can we take that 90-degree tester and put it anywhere on A on one of the angles? Let's carry down to here. So what do we learn about this angle? It is 90 degrees. And you can see that because our shapes are on a grid, the grid crisscrosses so that you should see 90 degrees at the corners. So this angle at A is 90 degrees. Let's look at the question up above. Which triangle below has an angle that is greater than a 90 degree? So this corner is not greater than. So this doesn't work. What about up on top? If we take that and we turn it, our angle up there is less than 90. Remember, an angle is basically how far one arm turns onto the other. It's a measure of rotation or turning. And we have a third angle. So we bring it down here and turn it back again. Can we see if our angle is equal to, greater than? No, it's not. So in angle A, none of the angles in that triangle is greater than 90 degrees. Let's do it for B now. Let's do the tester again. And we bring it in and take it and apply it to the left side corner. So the angle at the bottom left side of B is definitely smaller than 90 degrees. Let's try for the top. Take it and we'll turn it until one side matches, and notice the other side, the angle hasn't turned as large as it, so it's smaller than 90. Let's go to the third one, and if we turn it, we can see this angle here is also smaller than 90 degrees. So in triangle B, none of the angles are greater than a right angle. So let's go to triangle C. Let's bring up our right angle or quarter turn. And let's try it on the top angle. And as we turn it, we can clearly see that that is less than a quarter turn or less than 90 degrees. Let's try it at the bottom right side. And as we turn it, we can see that that angle there. Now you all can easily see this because it is a grid, so you can see what the quarter turns look like. So the bottom right side of C is less than 90 as well. What about this corner here? Look at the bottom of C, bottom left side of the base, and the angle is more than 90 degrees. So this is our answer. C is a triangle which has an angle that is greater than 90 degrees. And we could go through D as well, just to see it. So let's bring up the tester where we have our 90 degree. And if we bring it across to the top right side and turn it, that angle up there is less than 90. Bring it down to the bottom there and we turn it again. Our angle there is less than 90. And our third angle here, we turn it, you're going to see it's also less than 90 degrees. As such, C is the only one, the only triangle with an angle greater than 90 degrees. So now let's go on to number 18. And in that one, there we've moved to statistics, the last three questions on this paper. The tally chart below shows the months in which students in a class were born. The months in which students were born were January, April, July, and September. In January, there were 5 and one more 6 students were born in January. Nobody was born in February or March in this class. But in April, we had 5, 6, 7, 8, 9. So we had 9 students born in April. And in July, we had 5 and another 5. We had 10 students born in July, 6 in January, 9 in April, 10 in July, and nobody in August. But in September, we had 5 students that were born there. So these are the months of their birthdays. Which month represents the mood? So let's recall M-O-D-E, mode. It means which one of the months the students had the most birthdays. So most birthdays were in the month July because January is 6, April is 9, September is 5, and July is 10. July is the most frequent. So students, remember the answer would be July, not the number 10. They're not asking us what number it is, not how many, but when does the most occur? It occurs in the month of July. Let's go on to 19, which in that question, the table below shows Maddie's marks in her end of term test. So there were 1, 2, 3, 4 subjects that Maddie wrote, and her marks obtained were 80, 91, 82, and 53. What was Maddie's mean mark? So her mean mark would be like, what would those things average out to be? So we could draw a little sketch here. So you could see 80 to represent mathematics. Language arts would be higher, 91, social studies, 82, and science, 53. So all we're interested in is at least giving ourselves an idea of where the mean is. The mean is that we could redistribute these marks until everybody gets the same amount of marks. So Maddie gets the same marks in every single subject. If that's the case, then could the mean be 53, the lowest mark? If we left 53 across, then we'd have extra blue in math, extra in language arts, extra in social studies. So the mean could not be 53. Could the mean be 91? Could it be that when we redistribute the marks, we have enough marks to add to mathematics to make it 91 and social studies and science? No, we couldn't. 91 is too high, 53 is too low. As such, the mean lies somewhere in that space in between. This gives us a general idea of where the answer is going to lie. So when we talk about mean, what we really want to do is find out how much we have in all and then redistribute it evenly into how many subjects? 1, 2, 3, 4. 4 subjects. So how many marks do we have in all? How do we do that? We can work it out. We can say 80 marks in mathematics and 91 in language. And we'll add 82 to social studies and 53 in science. So if we add the ones column, we have 0 plus 1 plus 2. 1 and 2 is 3. 3 and 3 is 6. So we have a total of 6 in the ones column. And in the next column, we have 8. And 8 is 16. 16 and 5 is 21. 21 and 9 is a total of 30. So let's cross out the 0. And we can put it there. And then we have 3. So in total, Maddie got 306 marks in her 4 subjects. So what was the average mark for each subject? Well, we could have 306 and we're going to break it up into 4 parts so we can see how much each would get. So let's do some division. 4, can we say 4 divided by 3? Meaning, if we have 300s, can I break that up into 4 parts? I cannot. But if I have 30, could I break it up into 4 parts? Yes. 5 fours are 20, 6 fours are 24, 7 fours are 28. 8 fours would be too much. So 7 fours are 28. And how much is missing? 29, 30. We would have 2 extra. So 4 into 26 is 6. 6 fours are 24. 25, 26, we have 2 extra. What do we do with this 2 extra? Well, we could put that as a remainder there, but what we're really doing is putting a decimal point and adding a 0. So that 2 extra ones is really 20 tenths. So 4 into 20 tenths. Now we're dealing with decimals, so let's put a decimal point in our answer. Right? If we have 20, how many groups of 4 can we get? 5 groups of 4. As such, the average or mean mark Maddie would have gotten after her performances in her 4 subjects is 76.5. Let's go on now to the last question in this section, number 20. The incomplete bar graph below shows the color of the vehicles in a car park. So the color of vehicles in the car park, we have 4 different colors: red vehicles, gray, blue, and white. And the number of vehicles that go with them. How many red do we have? If we look at our scale, 2, 4, 6 is between 6 and 8, so there's 7 red vehicles. Gray would be 3. There's a little extra there, but it's 3. Has to be a whole number. It can't be part of a vehicle. We no idea what's going on with blue, but white, there are 8 vehicles. So if there are 24 vehicles in the car park, how many of the vehicles are blue? So what do we know? We know that there are 24 vehicles in the car park. So let's just bring this up so you can get an idea of what's happening. And of those, there are some which are red. How many are red? 1, 2, 3, 4, 5, 6, 7. There are 7 vehicles which are red. And how many are gray? 1, 2, 3. So if we add up the red vehicles and the gray vehicles, 7 and 3 will give us 10. And how many are blue? Well, we don't know, but we know white. So white will be 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 white vehicles. As such, red and gray and white vehicles totals 18. So how many are blue? The rest of them to reach 24, which is 1, 2, 3, 4, 5, 6. So we got our answer. It is 6 blue vehicles are in the car park. Some people prefer to work it a different way. We could just add it 7 red vehicles and 3 gray vehicles. That's 10 and 8. 18. So we can write it there, cross the 8 as ones and bring it up. And of course, there's only 110, so we can write that as well. So there are 18 vehicles, just as what we saw in the diagram. How many vehicles did we have in all? 24. And we know what 18 of those vehicles are, so the rest are blue. So 4 minus 8, that cannot happen. So we need to regroup. So we're taking 1 from the tens. And when we bring it across, 110 is how many ones? 10 ones. So 10 ones and 4 ones means we have 14 ones. 14 ones minus 8 is 6. And 1 minus 1, 110 minus 110 is 0. So it means we have 6 blue vehicles. So we have now come to the end of our SEA 2022 past paper questions. Section 1, those 20 questions. We started doing this series with the SEA 2019 paper. So you can find the links for those below. And going on to our next paper, SEA 2023. Thank you all. Take care. Bye-bye.